Okay, so in the last video we talked about we're going to solve something concrete. Um, and this is a question actually. A student 1.5 meters tall, when standing up, observed that the angle of elevation of the top of a tree 20 meters away is 25 degrees. Find the height of the tree. Okay, so this is the first thing. We have a student. So I'm gonna draw a very funny student here. So this is a student here, and they say this student is actually 1.5 meters tall. So he is one. Let's see. Let me not put that there. The student's height is actually 1.5 meters tall. So 1.5 meters tall here. Now, when standing, obviously standing, he observed that the angle of elevation of the top of a tree 20 meters away. So the tree 20 meters away from him. So if you look at it from where he's standing, let's say this is the point. Or let's say this is the point where he's standing. Let me use another color for that. So let's say this is the point where he's standing. 20 meters away, there's a tree. So this is 20 meters. 20 meters. My barrel has issues, but I'll just manage that. There's a tree. Let's use the color for the tree. Makes it interesting. So the tree, they say, is 20 meters away. There's a tree. So let's say this is a tree. We don't know what kind of tree it is, but this is a tree. Now, the question is find the height of the tree. But they said also that his angle of elevation is 25 degrees. So that means from the point of his observation, meaning that from the eye point to the tree is 25 degrees. You understand what I said there? The question is, a student is 1.5 meters tall, right? And when he stands up, he observed that the angle of elevation of the top of a tree 20 meters away is 25 degrees. So from this point here, he's able to observe, because this is obviously his eye point where he's able to observe. So from his height or eye point, he's able to observe that the tree is 25 degrees in terms of elevation. So from this point here, the tree is 25 degrees. So this is the diagram we can come up with, and they want us to find the height of the tree. So this is the tree, and this is the height we have to find. But how were we able to come up with this diagram? We just understood, first of all, that since they gave us specifically his height, that means the angle of elevation has to come from the top of either his head or his eye point, not from his foot. Because when they say he observed when standing up. So that means the point of observation has to start from this point here. Okay, so from this point here, he observed that there's a tree 20 meters away and an elevation of 25 degrees. So this is the angle of elevation, and you know that it is from his observation point, or the eye point. And this is 1.5 meters his height. Now they're giving us 1.5 meters here for his height, which will help us to be able to find the height of the tree. Because when he's standing, he actually takes 1.5 meters away from the tree. So the original height of the tree will be the remaining part of the tree. Let's call it, let's call this side the remaining part of the tree. Let's call it H1. H1, and this other side of the tree that his height has taken up, let's call it H2. Okay, so the H2 is obviously 1.5 meters, because that is his height, and that is the point of the tree where his height has taken over. So this point is 1.5 meters here, but we do not know H1, because H1 plus H2 will give you the height of the tree, right? Okay. But we need to find what h1 is first. I think that's the point. Um, how do we find h1? Okay. First of all, we know that since the distance between him and the tree is 20 meters, that means here also would be 20 meters because it's still the same distance. Whether from his eye point to the tree or from his leg point to the tree, it's still 20 meters. So yeah, this point here is 20 meters. So with this now, we can use our trig ratio to find the height, because we have here as opposite and we have here 20 meters as adjacent. So tan 25 degrees equals to h over 20 is exactly what we're going to do. Tangent is opposite of adjacent. I'm sure you know that already. I'm going to explain a little part of this again, just in case you still do not understand it. But let's just keep solving. So we have tan 25 degrees, tan 25 degrees is equal to opposite, which is h. Let's call it h1 because that's what we're looking for before we add it to h2 to get the original height of the tree. So h1 over 20 with 20 meters. So h1 is obviously going to give you 20 tan theta when you cross multiply. My battery is having issues. Okay, so when you cross multiply, you have tan 25 degrees, 20 times tan 25 degrees. What is tan 25 degrees? Tan 25 degrees should be 0.4663. I just hope that is correct. But you understand the whole idea in case it is wrong. But this is 9.3 meters. So that is h1. That is, let's say, from his head upwards, in terms of the tree. That is 9.3 meters. That means if you add 9.3 meters to the remaining parts of the tree, which he has taken with 1.5 meters of his height, it will give you the whole height of the tree. So this is what I mean here. If you have this part, we've gotten h1 now as 9.3 meters. We know that this is his height. If you look at his height from his height to the tree, this side here is 1.5 meters. That means this remaining side, which we've just found, 9.3 meters, we're going to add h1, which is 9.3 meters, plus h2, which is 1.5 meters, and that will give us the original height, and that will be actually 10.8 meters. So that is the height of the tree. Okay, so I think this is a little bit clear, but I think you should understand it. If you really understand the question, you should be able to understand how we got this answer, because everything is just based on the question. The question started with his height, 1.5 meters tall. When standing up, take note of that point, when standing up, a student when standing up observed that the angle of elevation of the top of a tree 20 meters away is 25 degrees. So they're not talking about when he's crouching or lying down or sitting down. They gave us his height. Told us that from his observation, meaning that from the points the eye point, that is the points of observation, looking at the tree 20 meters away, it is actually the angle of elevation is 25 degrees. So from the point where he's looking at the tree, from his eye to the top of the tree is 25 degrees in terms of elevation. So that is what gave us this idea that we have his height here, like this, and then from this point of his, normally we'll draw the triangle like this on the flat base, then go up like this. But this time we had to include his height, just because we know that there's a tree height we need to find. Okay, so that is just the idea. I think it's basically because of the height of the tree. That's why we are so passionate about the height of the student. So if there was nothing involving height of the tree or height of the student, I don't think we'll be including the height of the students like this. Yeah, we'll just do the normal way. Yeah. So I think you should just understand the question, you solve exactly as you see it, and you get your answer. We're going to solve another question, but this time it will be in terms of depression. That should be in another video, right? Yeah, should be.